Yeah, so we are going to learn the data stage jobs now. So in today's session, we'll be concentrating on the different types of data stage job, and then we'll proceed further for understanding what is partitioning and what is pipelining in data stage. So basically, data stage is two. I mean, there are three types of data stage job in total, right? So it will be better if I try to explain them with the differences that they have, so that you can. It will be easy to learn like what are the properties of each and every. Let's start further. So there are three types of data stage jobs. In data stage, we have three types of jobs. Okay. So in there we had already seen a few of the session before in which we looked into what basically we looked into the architecture of data stage. Right. In today's session, we are going to understand what are the different types of data stage job and how they are different from each other. What is the usage and advantage and disadvantage of them over each other? Well, on the same note, there are three types of jobs: server job, parallel job, and a sequencer job. Okay, server job and parallel job are the jobs that you can compare with each other. So we can differentiate among these two types of job, like what are the properties, what is the advantage and disadvantage. Sequencer job is completely different types of job. So there is no point of comparing this with this server parallel job, because the usage and the usage is completely different. The properties is completely different. So we will not bring that into picture when we are trying to compare server and parallel job. But at the same time, we will also understand the properties of a sequencer job as well. Now let's concentrate on the server and parallel job first. So server and parallel job are, so first of all, let's talk about the server job. Server jobs are the jobs. So when data stage start came up with, when Essential, it started server job. It created data stage. So basically, data stage is the product of Essential. So Essential came up with data stage software in say 15-20 years back or more, right? And the first version, so in the first versions and also they started with a server job version. In that version, there was nothing like parallel job or any other configurations. Only server job was there, because the data was not huge at that time, and so with less data, the performance was not at all the first criteria. So the server job used to work. Thereafter, because the performance used to get hit, they and IBM bought this data stage software. They created a parallel job option in this data stage, wherein the job gets executed in partitioning, pipelining, and the performance is taken care. Performance is the first priority in this set of jobs. So that is how it moved from server jobs to parallel jobs. And along with the parallel job, they also introduced, slowly, Essential itself introduced the concept of sequencer jobs in data stage. So it's like server job came first, sequencer job came second, and then the parallel job came at the end. Okay. Now let's look at server job. So what are the properties of server jobs? The first one is it executes in sequential mode. What does this mean? Sequential mode means it will execute in the data one by one, and it will execute each and every stage one by one. In the sense, just assume that you have a data stage job wherein you are using a DB2 stage, say a transformer. Let me put that as a XFM as a transformer, and let's say that the next stage is say a join, and the last stage is again a database, something like this. Just a sample example. So what happens in server job is the job will get executed in sequential mode, wherein if you have 1000 records, so 1000 records will be processed one by one. Second thing is, there is no buffering option here, so that if you have 1000 records, first the entire 1000 records will be pulled by DB2, or pulled by the DB2 stage. Once it has completed this pull of 1000 records, it will push this data into XFM stage. Then once XFM stage, which is a transformer stage, completes its operation, it will push this data to the joiner stage and then to DB2 stage. So Each and every stage is working one by one. It's not that this is called as pipeline. This feature has been overcome in parallel job by implementing logic of pipelining. Okay, so we talk about partitioning and pipelining. So we'll see in this, after once this topic gets completed. So we'll see what is partitioning and pipelining. So at that time we'll understand, right? So how partitioning and pipelining are an added advantage in parallel job, enhancing the performance. So at that time we also come to know what it will be much more clear probably with the examples that we are going to discuss, that how a parallel job implements partitioning and pipelining, and which were not there in the server job. So how the performance was there. So pipelining is not at all there in the server job. So there is nothing like buffering. So each and every stage used to wait for their own turn to get the complete set of data in one shot, and then take their own time to execute the job or process the data one by one, and whatever time it used to take, so that is getting because there is no buffering. So every stage is it's not like one stage is trying to do the processing, the other stages are idle, right? So this is what is called what was happening in the server job. So in server job, the data stage used to execute in sequential mode. No partitioning pipelining was implemented. Okay. Now, because partitioning and pipelining was not there and job was executing in sequential mode, right? So it was impacting the performance. So the job execution was very, very slow. So, okay, performance was slow. What else? Well, the engine, the data storage engine that was used to execute a server job, to compile and execute a server job, that is called as basic compiler. So basically, the server job gets executed in a server engine, and the compiler that it uses is called as basic compiler. Okay. So server engine and a basic compiler were used for a server job execution. Now these are precisely the difference, I mean the features of a server job. Now one last option is there which will make sense once we are done with the parallel job option. So let's go and look into the parallel job. What are the features of parallel job? Then we can differentiate between them. What happens in parallel job? It executes in parallel, not in a sequential mode like server jobs. It executes in parallel, implementing the concepts of partitioning and pipelining to increase the performance. Okay. Okay. And hence, because it's executing in parallel with partitioning and pipelining, so the performance gets increased. Right. Now, the engine that is used for parallel job is parallel engine, and the compiler that is used is OSH compiler plus C++ compiler. So these are the two compilers that is used for in a parallel job. Now, what does it mean by OSH compiler and C++ compiler? So why we are talking about two compilers in parallel engine? So well, in parallel jobs, parallel jobs has a stage called as transformer, and it is implementing partitioning, pipelining, and all of the stuff which is increasing the performance. So the capability of a basic compiler is not in terms with a parallel, so that it can execute a job in partitioning and pipelining, and that is the reason a new engine has to come into picture, which is called as parallel engine. And similarly, a new compiler came into picture, which is called as OSH compiler. Right. Also, data stage parallel job, we will be designing or using a stage called as transformer. Now this stage has huge amount of functionality in data stage. It is used to almost do most of the operations, or a considerable amount of operation can be actually implemented in transformer. Right. Now the transformer is actually executed by C++ because it uses lots of functions, inbuilt functions available in C++, and the execution and the compilation, everything of transformer happens in C++ code. So that is the reason the C++ compiler is used only for transformer part. So if at all you do not have a transformer in a job, you will be working on only OSH compiler. But if you're working on transformer in your job, then by default C++ compiler in addition with OSH compiler comes into picture to implement the requirement. So both the compilers will integrate together and perform the operation. That is the reason we say we have two different compilers in parallel job. And in parallel job, we have huge amount of inbuilt stages which are available. So inbuilt stages, like you will see in DataStage Designer, in the palette section, there are inbuilt stages which can be used for designing a DataStage job, right? Like join stage, lookup stage, merge stage. There are huge amount of stages, which is not there in a server job. So server job is lagging in the number of stages that is available. Okay, this is another difference of now the benefit of having huge number of stages in DataStage parallel job is for implementing any kind of business requirement, we need not worry about how we have to do it, because for almost each kind of setup, each kind of requirement that can possibly come, IBM has created a stage for that which you can easily use and implement the business requirement. So that makes it very flexible for the users to design DataStage job. Is that clear? The server job and parallel job components?
Yes.
Okay. So now let's talk about the sequencer job. So first of all, what the sequencer job does. So we understood that the server job and the parallel job actually help us to implement a business requirement. Implement a business requirement in the sense. So when business gives you a requirement like, okay, you want to fetch the so this is my source table, these are the different transformations that I'm looking for, and this is how I'm looking for the data to be converted, and this is the target. So we can implement these kind of scenarios with a server or parallel job. Parallel job being more performance friendly, so and we are having huge amount of data these days, so we will go with the parallel job mostly. But and we do not want to code a lot, because in a parallel job we had huge good amount of stages available for which the coding is not required, so we do not want to code a lot. But if at all you are interested in a lot of coding and you want to execute the job with a slow performance, yeah, you can definitely go with the server job as well. Depends on if if at all that is installed on your system. Sequencer jobs are not at all related to implement your business requirement, like pulling the data, fetching transforming the data, lookup, join, and then loading the data into the target. So sequencer jobs has no relation with all these kind of activities. So then what is sequencer job used for? Okay. Did you ever get a scenario wherein you have implemented say 3 jobs, say job A, job B, and job C, and do you think this kind of scenario is possible? That's what I'm just trying to ask. And the business, and at the end when you implement you got a requirement, you splitted it up into situations, and you created 3 jobs, and then you're thinking, okay, now my jobs if I execute the 3 jobs in such a way that if my job A is successful, if the job A gets completed successfully, go execute job B. But if the job A got aborted because of some reason, right, you should execute job C. If did you ever face a situation, you may end up in some scenarios that you have to design certain jobs with this kind of requirement. Now you cannot do this with the parallel job, but you can do this with the sequencer job. This is what sequencer jobs are used for. So basically, what we call it the sequencer job as, we say sequencer jobs are used for controlling the way the DataStage server or the parallel job gets executed. Okay, so it controls the execution pattern of a server or a parallel jobs. Now remember, I am talking about both the server and the parallel job. I'm not saying either the server or the parallel or only the parallel. It's both. So sequencer job can execute both of them. You can also design a sequencer job in such that in one sequencer job you have a server job and you have a parallel job both. Quite possible. Not, I mean, it's not like it's a new stuff. But then how this sequencer job gets executed? So because I'm saying that it is implementing a parallel job and it is implementing a server job execution both, then what is the compiler for a server sequencer job? What is the execution method of a sequencer job? What does it do? Right? And how it is able to execute both the server or the parallel jobs. So basically the sequencer job, it gets executed by a server engine. Okay. Right? Again, basic compiler. Sequential mode. Right? Now, so if you see all these options that I mentioned, it's executed by a server engine, see basic compiler, sequential mode, all of these are nothing but the properties of the server job. So then the question comes is, how, looking at this, one can be very much sure, okay, the server job will be able, sequencer job will be able to execute the server jobs because they are in the property wise they are in sync. How can a sequencer job execute a parallel job? Right? That can be a question. Correct? So this is how it happens. Basically, as I told you, sequencer job is just a control structure. So it's just trying to control the way the job gets executed. So basically implement the dependencies between the job, whether it be sequencer job, server job, or a parallel job. Okay. In the background, right, it's executing the sequential mode like one after the other. Okay. So it's executing one after the other. Obviously, when you are executing something in a controlled structure method, it will be executed one after the other. You can start from left and you can end till the right, so it will be like one after the other execution. So that's also makes sense to me. But how come parallel job gets executed if I'm trying to? So if I try to execute a parallel job through a sequencer job, it will lose its property of partitioning and pipelining, because then the sequencer job is getting executed by basic compiler, server engine, etc. This parallel job should also get executed by how it will go, the execution will happen in the parallel engine in that case. Right? The question is there. Well, as I told you, sequencer job is just a control structure. It just controls the way the parallel or the server job gets executed. So once, suppose you have a datastatic job wherein you have, say, a server job, then you have a parallel job, and then you have a server job again. So what the sequencer job will do is, it will invoke a server job first, wait for the output. Based on the output and based on the trigger condition that we will provide, to invoke the parallel job. Now the server job is pretty much simple, that it will go ahead and execute it in the base server engine with the basic compiler and stuff, other stuff. When the control comes to the parallel job, the sequencer job only invokes the parallel job. So it's like the transfer of control. So the moment sequencer job invokes the parallel job to get executed, the control of execution gets transferred to the parallel job. Thereafter, how the parallel job gets executed is something that sequencer job is least bothered about. It does not care. So either it is getting executed in server engine or a parallel engine, not interested to know. It's least bothered where it is getting executed. What it is now, the next step that sequencer job is waiting for is a return information from a parallel job, like what is the status of the job, based on which it can compare whether it has to invoke the next sequence server job or not. Right? So does that make the entire execution properties of a sequencer job clear? How it happens? So if you want to think it in this way, then you can think like, okay, the server jobs are nothing but a business. So the business management, they just want to get something done, right? So they come up to, say, consultants or to consultant firms and say, okay, this is what I'm looking for. Can you go ahead and implement it for me? The firms are behaving as a parallel job wherein they will take the requirement, implement it, and suppose use more than one individual to get the operation done. So implement the logic. They may use one or more resources, or they may have more than one project and get this entire requirement of the business done. And then once it is done, hand over the project to the client again, back to the client. So this is just an example. So what happens when the business is giving the requirement to the vendor or to the consultant companies? They are least bothered about how they get executed, how they are going to implement it. They're implementing it in one project or two projects or multiple projects, or they're implementing it in say by using only one resource or two resources or n number of resources. So how they are going to do it, least bothered about it, right? Other example that you can think of is like a cloud database. So if I'm looking at a cloud, right, I don't know how many my data is stored in one server in the cloud or multiple server in the cloud. I'm not aware about how it is done. The only feel that I can get is, okay, the data is there. It might be stored in different format, but I'm able to see everything, right? How in the background the things are happening, I'm least bothered about it. So that is what sequencer job role is all about. It just that, okay, some things are happening. What logic the parallel job is implementing or the server job is implementing, that is something which sequencer job is not interested to know about. Make sense? Any doubt here?
Yes, Anshu. Yeah, I have a question. This is Radu.
Yeah, right.
So the server jobs and the sequencer jobs, I think, are clear. I have a question related to the parallel jobs.
Go ahead.
I mean, when a compiler is used, when a specific compiler is used, so let's say we have a straight-through load. When we want to load the data from a CSV file into a DB2 table, no transformations, nothing, just load the data. Then I think the OSH compiler will be used. Only yes. OSH compiler will be used, right?
Yes. The moment okay, so let's think it this way. The moment you add a transformer in a data stage job, okay? The moment you add a transformer into job, then C++ compiler comes into picture to help or to rescue OSH compiler, because OSH compiler cannot compile or execute the transformer component, which is a part of the C++ coding. So in that case, the C++ compiler comes to rescue this OSH compiler. Right. Otherwise, OSH compiler is self-sufficient to compile and execute the parallel jobs.
So whenever we have a transformation, an aggregation or a lookup or any kind of calculation,
only transformation, only transformer.
Oh, so what do you mean by transformation?
So there is a stage in data stage which we'll see in some when we are looking into data stage designer. There is a stage called as transformer.
Oh, I see. Okay.
So when we use that particular stage, only then the C++ compiler comes into picture.
Oh, I got it. Okay. All right. Okay.
If that stage is not at all used in the data stage job, in any specific data stage job, the complete execution will happen from OSH compiler.
Okay, I got it. I wasn't familiar with that stage, so that's right. Yeah. So yeah, I think it's clear now.
Clear? Any other doubt?
Nope.
Okay. So this is all about the server and the parallel jobs and the sequencer job. We can go through the PPT. If there is any point missing, we can discuss on that. So as you see, the parallel jobs are executed by the data stage parallel engine. Pipelining and partitioning are implemented. OSH compiler is there. So OSH compiler, you have another component called C++ class instance, which is like along with the OSH compiler, it comes into picture, right? Then job sequences it's used to control the jobs, the master server job, that kickoff job, and other activities, right? Runtime monitoring is there, executed. This is executed by the server engine. We have already discussed, right? The server job executed by the server engine, compiled by basic compiler. We have discussed more options, but only limited informations are available in this PPT. So I just hope that all the three different types of jobs are clear. If you have any doubt, you can ask me right away, or else we'll proceed with the next topic. So the next topic is partition and pipelining. So before we go ahead and look into like how partitioning and pipelining gets implemented, what are the algorithms are available? So there are close to 9 partitioning algorithms and 4 collecting algorithms. So let's look into what is first of all partitioning, right? And then we look at how partitioning is going to enhance the performance of a data stage job. So in basic nutshell, precisely if I want to learn or I want to understand what is partitioning, okay? So what is partitioning is, okay, I'm just trying to cite some examples so that the concept of partitioning becomes much clearer, okay? Now before we go ahead with that, in the example section, there are some assumptions in this example. So the assumptions are, each and every individual have the same capability, okay, and they can deliver the same. If I give a job to say person 1 or person 2, both of them individually will take the same amount of time because they have the same capability to complete a task. So having said that, let's go ahead and look into an example. Now just think that you're working for a company, right, and the project manager of that company got a requirement from the business. So the requirement that he got is he got 4 independent requirements. That means he got 4 requirements for which data stage job has to be created, some data stage job that you have to create. These 4 requirements are such that each and every requirement can be implemented independently. There is no dependency between these requirements, okay? Now because there is no dependency between these requirements, you can just go ahead. So if this requirement comes to me for the job development, suppose I am the only person in the project who has free time, who is not available, who is freely available basically. So then the project manager will come and say, hey, this is the requirement, these are the 4 requirements, can you work on these 4 requirements? And I will start working on them because I know that they are independent of each other. I can take up any one requirement on day 1 and I will start working on it. Now let's assume that each and every requirement takes 1 day for completion. So I can take any requirement, say requirement 1, requirement 2, requirement 3 or requirement 4. Each of the requirement takes 1 day. So it will be like whichever requirement I take, it will take 1 day for me to complete. They are independent of each other. So I need not worry about the dependencies which is there, so that if I have to follow a particular order for the job design or job requirement development. So if we look at all the situations, I can say that I have a flexibility of creating my data, picking up any requirement on day 1, day 2, day 3 and day 4 and complete the requirement on that individual day. I can do that, right? Now, so for completing this 4 data stage job requirement that the business has got, or that my project manager has got, because I was the only person who was available for the job development, it took me 4 days to complete the requirement. Now the manager also, he looked into the requirement and he thought that okay, probably this is not the timeline that I have to complete it in 2 days. So then that means I know if this is the kind of situation, this job will not, at any cost, this job is not going to complete, or the entire 4 set of jobs we cannot complete and deliver in 2 days. So then what is the next step we should take? We should add more people. Clear cut? So we should add more people into this, so that when more people are there, the time taken will get reduced automatically. Okay. Now, so what the manager will do is, instead of assigning it to only me, he will say, let me add one more person, and these two will be able to complete the job design in 2 days, and the job will be successfully delivered in 2 days, because I've already told you the first assumption is the capability of each and every resource is same. So you have 1%, 2%, or 4%, or whatever. The capability of each and every person is same, because of which whether I take up a job or the other person take up a job, both of them will be able to do the same job, take the same amount of time to complete that particular job requirement. Okay, so I will be able to complete it in 2 days. Okay, now just think, okay, this is one situation. How about the project manager wants to complete it in, say, 1 day? So then he has to, instead of assigning it to 1% or 2%, he has to put in more resources, more people to get it done, so that the task gets completed in 1 day. Make sense? So if he adds 4 resources instead of 1, and all 4 of us, we start taking up one requirement and start designing the job for that, all of us at the end of day 1 will be able to complete the entire 4 requirement. Make sense? Now, so here you saw that with the increase of the number of individuals, the performance is getting increased. So this is actually the concept of partitioning. So the project manager has actually partitioned the requirement into multiple and allocated it to multiple people. So this is what is done in data stage. So it partitions. Now it does not partition the script, meaning when you design a data stage job with, say, 4 or 5 or 6 stages or whatever, it does not say that, okay, stage 1 you will get executed by, say, server 1, stage 2 you will get executed by server 2, stage 3 you will get executed by server 3. No, what it says is it keeps the script intact. So each and every server will execute all the different stages. So stage 1, 2, 3, 4 will be executed by each and every different server. But along with that, what it also does is it adds up a part of, or it adds up a contribution of splitting the data. So what I mean to say, has this job been executed by a server job, and you have, say, 1,000 records, you have 4 stages, so all the 1,000 records would have been executed by the server job one by one in one server itself. Like all the 4 jobs were executed or were implemented by me all alone, and I took 4 days to complete it. In the same way, when you're using a server job for this data stage job, for this data stage job which has 4 or 5 stages, and you have 1,000 records, so it will be executed in one server. All the 4 to 5 stages will be executed by the server job. But when you're implementing it in parallel using parallel jobs, right, and you have, say, 2 servers, so then the total record of 5,000 will get splitted up into 2 different parts, 500 and 500, and these 500 records will be pushed to 2 different servers where the job is getting executed. So both the 500 records are pushed to 2 different servers, and the job execution will happen at these 2 different servers. Clear? Now, point to note is, we are not going to split the script, the OSH script that gets created. We are not going to split it. We are going to split the data that is available. So the data is getting split into 2 different partitions and getting implemented or getting loaded into the and goes to 2 different servers for the execution. If business wants more performance, so what they can do is they can add more servers. So obviously, if I'm executing 1,000 records on server 1, it's taking, say, 1 minute, or say, let's take 4 minutes of time to get executed. When I will be executing the same job on 2 servers, obviously the time will get slashed by 2, so it will take 2 minutes to get executed. When I will use the same requirement, same data, get executed in 4 servers, Each server will get 250 records to execute. So then the total time taken by each of the server will be slashed by 4. So we started with 4 minutes. It will become 1 minute for each and every server to execute the job. Execute the job in the sense, because the number of records are getting reduced in each and every server from 1000 records to 250 records. Now when 250 records are going to one server, it will take obviously 1/4 of the total time it used to take for 1000 records, which is 4 minutes divided by 4, which is equal to 1 minute. So now each server is taking 1 minute for the total execution. At the end, the data is collected. After the total execution of all the 4 stages, 4 servers happens, the data is collected, and the collected data is again becomes 1000 records. So the performance get enhanced by implementing it in partitioning. I just hope it's clear.
I'm sure I have a question. When you say server, one or more servers, do you mean the engine tier of the IIS?
Yes.
Okay, so we can have
we can have more than one
service tier, but we can have multiple engine tiers.
Yes, we can install multiple engine tier on multiple servers, and so we'll look more in the sessions to come, where we'll look that there's an environment variable called apt-config file, wherein we can provide the configuration which should be used for a particular job to get executed. This configuration file informs data stage on what are the servers this particular job has to get executed.
Okay, great. Okay.
So things are yet to come, right? Now, so it will be much more clear when we actually start going ahead. So we just started the session, right? We just started learning what is data stage and other stuff. So obviously things will be a little glimpsy, not to worry. Things will be much more clear. The complete session is designed in such a way that you will, at the end, once you're learning things slowly and you're going towards the end, whatever we have learned you will feel that it's going to make sense. It will start making sense to you very, very clear. So that is the part. Now one more point I want to add here. So if you take that project manager example, wherein the manager was wanted to get this job implemented, to get the requirement implemented, right? So he started with so we started with one person, we added one more person, and it was like the job was designed by two individuals. It took 2 days. We added 2 more people, and the job was designed by 4 individuals, and it took 4 days. Now my question is, so that means if we keep on adding the number of individual or the number of servers, if you just think, now this is just an example I'm talking about. So if you keep on adding the number of servers, will the performance keep on increasing? So if I keep on adding the number of individuals who is going to implement this job, this four requirement that the project manager had, if we keep on adding the number of individuals, so from 4 I say 6 or 8, then am I going to get the total job design in half a day or something? No, right? Not possible, because I told you it's not possible that somebody who will so you split a requirement into 2 different parts, because inside a requirement, the requirements are independent of each other, but inside a requirement each and every component is dependent of, or has to be dependent of each other. So then you cannot split the requirement into 2 and say, okay, you do half and you do half. Make sense? So after a particular, so what I'm trying to convey here is the performance keep on increasing till a certain extent. Thereafter, even if you add the more number of resources, it's not going to impact anything or change anything in terms of performance, right? So I will put some more examples. So let's put an example to understand this more clearly. Okay, so just think that you have 1000 records. Simple example. Okay, you have 1000 records. These records are about say account holder of a company. the column that it is having is account number, account name, the gender of the person, and business has given you a requirement to find out how many males and how many females are there in the total, I mean, has opened the accounts in total, right? Now I'm just assuming here, right, that the number of individuals are equal, so there is 500 males and 500 females. Okay, now when I use the gender as a key column to implement my partitioning so that the data gets divided into two different partitions, we'll look into like how a key column or how a column can be used as a key column to implement a partitioning in the hash partitioning model. So we'll look into the algorithm and we'll try to understand how that happens. But as of now, just think, if you're dividing or making sure that all the males are going to one server and all the females are going to another server, right? So from one server, from a job execution when you have only one server to get executed, when you move to two different servers with all the males execution happening in one server and female execution happening in the other server, obviously the performance will get half. I mean, increased. Time taken will get half, performance will get increased double, two-folds. What will happen if I try to add two more servers to this? Instead of having two servers, if I have four servers, four engines, and I'm trying to execute the same job, I'm trying to make sure that all the males are on server 1, all the females are on server 2, and still I have two more servers. But because there is no more data to go to these two servers, although being there, are not doing anything, they are idle. So I'm not, even if I'm adding more servers into my system, I'm not going to, or I'm not able to utilize them to their fullest. And that is the drawback, or that is the bottleneck that we get when we keep on adding the number of servers to a data stage for a data stage job execution. Is that clear?
Yep.
So the key point to note is adding number of partitions or number of engines to a data stage job increases the performance to an extent beyond which adding the number of resources or the number of servers is not going to increase the performance. Okay, and at a certain situation it can also affect in reducing the performance. So we'll talk about how the reducing of the performance will come into picture when we are trying to learn the algorithm. At that part I will explain you like how the performance will get increased, but then at a certain point or the performance can also go down. So we'll look into that part. Okay, this is clear. There is now partitioning and pipelining. I will be going a little slow on this. It is very important for you guys to understand this topic. Okay, we'll stop here today because for going for, I mean, you can yourself understand in tomorrow's session that why I had to stop here and I cannot go further from this point. So I'll stop here and we'll talk about the other stuff of partitioning and pipelining and how it is going to impact the performance in detail in tomorrow's session.